Dear students, after the discussion of distance and displacement, speed and velocity with their differences, now our topic of discussion is acceleration. It's a very important topic in the motion, in mechanics as well as in kinematics. Acceleration is defined as rate of change of velocity is called acceleration. As in previous lecture, we have discussed that rate mean dividing by time. So acceleration is defined as rate of change of velocity. It's mean that velocity should be divided by time because rate mean dividing by time. So acceleration is actually rate of change of velocity. It's mean that formula of acceleration can be written as by definition that acceleration is equal to change in velocity over time. Why? Because time means rate. So rate of change of velocity is equal to acceleration. Next, this is the also definition as well as it is a formula in words. Now we are coming towards the proper formula with the symbols. Acceleration can be written as change in velocity mean final velocity Vf, V for velocity, F for final, minus initial velocity. It's mean that whenever we are subtracting initial velocity from final velocity, we will get change in velocity. And dividing by time mean rate. So we can write as rate of change of velocity is equal to acceleration. Student, how can we say that? Whenever we are subtracting initial velocity from final velocity, we will get change in velocity. This was actually change in velocity over time, the acceleration formula of acceleration. Then we put here that final, if we'll subtract initial velocity from final, we will get the change in velocity. I'm giving you a very simple example to explain this. For example, a car was moving with velocity 5 meters per second. After time, for example, 1 second, its velocity becomes 7 meters per second. It was 5, now it is 7. How was the change? Change is 2. And how did you find it? Actually, you have subtracted final velocity, that is 7. From final velocity 7, you have subtracted the 5, that was initial velocity. Then you get change in velocity is 2. So student, it is very clear that to find the change in any physical quantity, we must subtract initial value from final value. So yes, this is the change in velocity. And whenever we are going to divide it, it becomes acceleration. And so let's keep it in mind. This delta is also a change. So we can say that rate of change of velocity is equal to acceleration. I think so. Using the definition, now student, you are able to write the formula after the definition with proper conceptual understanding. Is that clear? Now, unit. Now, we are going to write the unit of measurement of acceleration. Students, before writing the unit, I'll again start from very base. And base was, first of all, we are interested to find the unit of velocity. So velocity was equal to displacement over time. And we know that displacement is measured in meter. So we can write here meter, that is the unit of displacement, and second, that is the unit of time. So it is equal to meter per second. We can write as whenever second is coming in on numerator, it is, there will be a negative minus 1 power. It is, and now this is known as, it was meter per second. Now we can also read this as meter per second. This is the unit of velocity. Now students, change in velocity, that is actually by nature, that is velocity. So unit of change in velocity is also meter per second. And we can write as change in velocity, its unit is meter per second. And what is the unit of time? Again, second. Time is measured in second. So second, writing with this, when it will come on numerator, its power will become minus 1, it was already in numerator, now it is moving upward, so its power becomes minus 1. Now it's equal to meter per second square. Why? Because both, whenever bases are same, according to mathematics, you know that whenever bases are same, their powers will be add up and it is equal to minus 2. So this is the this is called meter per second square, and we can also write as meter per second per second. I think, student, it is clear. So we can write here the unit of acceleration is, we can write in this way, meter per second. This is the SI unit. We can also write kilometer per hour, kilometer per minute, but the SI unit is normally meter per second square. Is that clear, students? Now, students, what is the nature of this acceleration? So its unit can be written as meter per second square or meter per second square. In both way you can write. Okay. Nature. It is it the scalar quantity or vector quantity? So for nature, we have also discussed in previous lecture that nature velocity is a vector quantity. Time is a scalar quantity. So velocity over time, vector over scalar, acceleration is also a vector quantity. So by nature, keep it in mind that acceleration is a vector quantity. Next, types of acceleration. First type of acceleration is uniform acceleration. Uniform means constant, which is not changing. But I have observed that many students are doing mistakes to understand this uniform acceleration. So I'm going to explain that. How can we say that this acceleration is uniform? If velocity of a body is changing equally in equal interval of time, velocity of body is changing. Why? If velocity of body is not changing, students, then acceleration is zero. Velocity is not changing, it means final velocity and initial velocities are same. For example, I'm saying that velocity is not changing. So velocity, if velocity is not changing, it means that velocity is constant. Velocity is uniform. We are going to discuss here uniform acceleration, not uniform velocity. So for acceleration, there must be a change in velocity. Velocity should change. For example, if velocity is constant, velocity was 20 before some time, and now again the velocity is 20. So student, 20 minus 20 is also equal to that becomes the 0. Is that clear, students? So keep it in mind. If velocity is constant, then acceleration is 0. But velocity must change for constant acceleration. And how the velocity should change? Velocity should change equally in equal interval of time. Students, I'm giving you the example of this. How can we say that velocity of a body is changing in equal interval of time equally? So example of that is, for example, we know that acceleration is equal to change in velocity over time. For example, students, in first 2 seconds, for example, change in velocity is 4. So change in velocity is 4. So we will get 2 meter per second square. That is acceleration. Then students, I'm saying that next 2 seconds, for example, total time is 4 seconds. Next 2 second velocity is also changing now. In first 2 second velocity was changing 4. Now in next 4 seconds velocity is, for example, 8. And next in third second, next in, for example, in 6 seconds, now velocity is 12. Students, here velocity is changing because in first case velocity was changing 2 meter per second. In second case, in 4 second, velocity is changing 8 meter per second. And next 2 second, actually students, from here to here, the time interval is changing by 2 seconds. Time interval is changing by 2 seconds. Then students, from here to here, from 4 second to 6 second, again time is 2 second. So these intervals are equal. Now we will check that velocity is also changing equally in these intervals, because interval from here to here, time interval is 2 seconds. From here to here, time interval is again 2 seconds. Now I'll check that velocity is also changing equally. So students, from here to here, 4 was the change in velocity in first 2 seconds. Now 4 seconds, in total 4 seconds, the change in velocity is now again, students, 4. Mean 2 seconds were interval, and velocity is changes by 4 meter per second. And now from here to here, 4 to 12, again students, velocity is also changing by 4 meter per second. So we can say that, yes, we can say that velocity is changing equally, because from here to here velocity has been changed by 4. From here to here velocity has been changed by 4, and interval we have considered equal. So this is uniform acceleration, students. Velocity is changing. Velocity is continuously changing. For example, in first case velocity was 4, then it becomes 8. Change in velocity, for example, change in velocity is 8. Total velocity we can say that 12, that is. But the point is that velocity is changing, because here on the placement of delta v we have written the value. This is the change in velocity, and we are writing here change in velocity 4. Change in velocity from here to here, again velocity is being changed by 4, and from here to here velocity is changed by 4. So in equal interval of time, in 2 seconds velocity is changing, and in every 2 seconds velocity is changing by 4 meter per second. And then students, by dividing the change in velocity with time, here we get 2 meter per second square. Then students, again 4 2s are 8, we will also get 2 meter per second, and 6 2s are 12, 2 meter per second square. I think so. Now this concept is clear that for uniform acceleration, velocity should change equally in equal interval of time. If we are considering the equal intervals, for example, we are observing on stopwatch, then in equal interval of time, velocity should change equally. Then we can say that this acceleration is uniform, students. Otherwise, it is variable acceleration. Now at this stage, we are not going to discuss that, but that is uniform acceleration when velocity of a body is changing equally in equal interval of time. Then next, positive acceleration. Whenever velocity is increasing, then acceleration is positive. Why? Because mathematically we will get the positive value. Students, formula for acceleration is that final velocity minus initial velocity over time. If velocity is increasing, then final value will be higher than initial value. So this value will be higher, more than this value. Automatically we will get the positive answer. For example, I'm saying that in previous, for example, before 1 second velocity was 5 meter per second. Now velocity is 8. So now velocity is 8. It means now final velocity is more than initial velocity. So when we subtract 5 from 8, we will get the positive answer. So acceleration will be positive. So whenever velocity is increasing, then acceleration is positive. But when velocity is decreasing, for example, in previous 1 second before, velocity was 8. Now, for example, it is velocity of a car, and a driver is applying the brake. Now velocity in 1 second decreases from 8 to 5. It means now final velocity is, students, final velocity is 5 and initial was 8. So subtracting 8 from 5, we will get the negative answer. Keep it in mind, student. Mathematically we say that. Mathematically we can say that whenever velocity is increasing, we will get the positive acceleration answer. And when velocity is decreasing, we will get the negative velocity, because we have just one formula, final velocity minus initial velocity. This was the overall types of the, you can say that types of the acceleration as well as the acceleration that we have discussed. Okay. At your level, we are students at 9th or metric level, we are discussing the types of acceleration till this negative acceleration. Okay, students, love face.